Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben uw gast Ronald Kers en met mij is zoals altijd...
Hallo.
De enige echte Jan Stomphorst. Jan, dag 2, DevWorld.
Nou, zo. En we hebben een ander onderwerp dan normaal. Iets minder over Kubernetes, maar meer over open source.
Ja,
en leuke dingen.
Communities. Dus dan dacht ik dat is misschien wel eens een keer een leuke change of pace. To have a guest in the podcast. So I would like to welcome Claude Warren. Welcome.
Thank you.
And Claude, for the people who don't know you yet, can you please introduce yourself to our listeners?
Sure. As I said, I'm Claude Warren. I work for a company called Ivan. We do database hosting, basically on the web, on various cloud providers. But
What kind of database? Sorry.
Anything open source, basically. There's a whole list, but if you want Postgres,
Mongo.
yeah, basically anything that's open source.
Not Elastic.
No. Yeah, finish.
Sorry.
Already going to be in trouble for not having exactly the phrase I'm supposed to use when I'm not. I haven't, but across multiple cloud platforms, so you can spin up the databases and to make them talk across platforms if you want, or move from one to the other, things like that. But I work in their open source program office, and so that's how they support open source. Then I was basically hired to work on Apache Cassandra.
Okay, cool. Great database.
So yeah,
Awesome database.
It's really interesting underneath the hood as well. So it's got some interesting stuff coming in 5.0. Actually, 5.0 is just out. So there's some interesting things that have come along with that. And
You're interesting geek? What kind of interesting geeks?
well, there's a new consensus protocol that's coming along, and that's coming out in 5.1. That was supposed to be out, but you promise a date, and then you have to kind of try to make that date, or you can promise functionality, and then you don't have to worry about the date. But a date was promised, and so 5.0 is shipped, but it is shipped without the new protocol, and that's being worked on. It'll be out soon.
Okay.
When it's ready, when it's baked, when it's correct, we'll get it out.
Okay.
But is the Cassandra then the best database in the world?
God. Depends on what you're doing. It depends on what you're doing, right?
Yeah. Well, that was a question I have.
Sorry.
But maybe to take a little step back, maybe can you tell us a little bit more about your history, how you got involved in the IT and ended up in the Netherlands working on databases?
Oh, how again? It's okay. Amazingly, whenever I give a talk, I always talk about my family, and so that question actually comes back to my family. My father was an anthropologist, and I was at university, and he was teaching at the university I went to, and he came to me one day and he said, "You should take a computer class because I need some help analyzing this data."
Okay.
And I said, "Yeah, okay, I can do that." Little did I know that I would be doing computer stuff forever after that. And so that's how I got started looking at computer software. I actually got a piece published very early on pottery analysis in the Muddy River pottery analysis in Nevada.
Okay.
So, but over time it moved along and began to work in C and C++, and then Java came along, and so I started working in Java. I remember working in Java 0.8.
Oh, that's some time ago.
So that's that was a while back. And moved forward. Ended up, I really got involved in open source, working on a project. I moved to Ireland and was involved in a project doing medical research where you have researchers studying various cancer drugs. And they would have tools that would analyze whatever drug they were working on, and then they would be able to mix the data from that with data from massive databases and be able to run queries like, I found a drug, but it happens to be lethal, so I want to find a drug that looks like this one and has been published in a journal in the last 5 years.
Okay. Oh, yeah, sure.
And to do that, we used RDF across multiple very large database sets that are out there. And so I became involved with Apache Jena and began to work with that, and got into the Apache Foundation there, and started working on open source in a very significant way. Before that, I remember doing things like shareware and. You go back in time for it.
I know shareware.
Yeah, remember shareware? Okay.
Yeah.
You remember FidoNet?
No.
No, that was a bulletin board network that connected bulletin boards together before the internet. And you could send email anywhere in the world, basically. I'm using FidoNet for free. I've been dealing with email since before the internet, and flame wars since before the internet. Yeah.
Cool.
Okay, nice. But so you're focused on the databases. So
I focus on interesting problems.
Oh, interesting problems. Okay, let's say I have a problem. How do I know which database fits my problem? So you have you have Postgres, Cassandra, MySQL, Microsoft SQL. I push them in a little bit, but there are a lot of databases here throwing around, and also in the combination with Kubernetes we hear. Does Kubernetes work? Doesn't database work in Kubernetes or not? Should you do it or not? But for me, the question now is, what's the difference between the databases? Why should you use Cassandra over Mongo, for example?
I think you need to look at a couple of things. Okay, first off, if I was just going to come at this out of the blue, I'd say use a graph database, because all data is a graph. And my experience has been, you may think you know your data set, you may think you understand exactly what's going to go on, but as soon as you are done with building your tool or your project, whatever it is, and you get people using it, they will all of a sudden use it in ways you never considered.
Yeah.
And so your data structures will be wrong. So you want a data structure that's going to allow you to change and evolve very rapidly, and a graph database will let you do that. And a graph database probably really can model exactly what it is you want to store. Okay, that aside, you're going to want to look at what is it that you know. You have to support this, right? So you want a database that you understand, or that the people you are working on this with understand. And that's going to guide you in a direction. And then I think you need to look at, what else is similar in that space. If you look at MySQL and Mariah, you've got two that are basically the same. You've got Cassandra, and there's some other tools that are similar to that. So look in that space, and then and look at what the tool offers that you think you need, and go with that.
Okay.
So it's really horses for courses.
Yeah. Okay.
But a good graph database, say.
Oh yeah.
And what is the
Well, I work on Apache. I work on Apache Geneth, and so I am a big fan of RDF data.
Yeah.
Because it allows you to describe everything, and a lot of the property graphs, I think, have a problem in the way that they're designed. In that, if you have if you've worked with XML, you know that you have nodes and child nodes, and you have properties.
Yep.
of the node, right? And you think you know your data set, you think you know what your users are going to use. So you go, that is a property of this node, right?
Mm-hmm.
All right. And it goes out there, and then they use the tool in ways you never imagined, and all of a sudden you realize that property needs to become a child node. And now you have a problem, because all of your queries that access that, or that depend on and checking that in any way, have to be changed, because now that property has become a child node, and it's a different access path.
All right.
So graph databases do this, or the property databases do the same thing. They have these properties, and they have child nodes. They have the distinction. The RDF doesn't have that distinction. So you have the property. It's a first level citizen of the graph, and everything's first level citizen. So there's no divergent path for querying whether it's one type of property, one type of data or another.
But if I think about a relational data model, so really simple, like I've got an address, I've got people who are living there, and they're living on that address. How do I translate that to an RDF model then? Is that a good way then, or maybe rephrasing my question? Should I use then the RDF model, or should I stay in the relational database model?
We're going to go back to.
You got a lot of questions about this stuff.
So what do you know? And you probably know relational, and unless you want to take the time and understand how RDF works, then the relational model may be the best answer to get something out the door quickly. The relational model, you have a table, and so you have the rows in the table have a primary key.
Yeah.
Right? Okay, so if you think about the primary key, you can say, okay, that is a node in the graph. And then the data that hangs off of that, so every column in the table becomes a property in the graph, and then the value in that column becomes the subject predicate object, becomes the object in this statement. RDF is a very simple statement. It's a subject predicate object. So it's, this thing has this property and this is the value for it. So you can take a table and decompose it that way. And then you say, well, this primary key, this thing that was the primary key, that node, you say, oh, that's of this type, and that type would be associated with what you store in that table. So you have a table of people. You put the primary key for the person, and then you list all of their properties. And then you say, well, that person, that primary key, is of type person. So now you can say, well, show me all the people, and you can basically do what you can get what was in the original table.
But are there still relations between nodes of?
Sure. Yeah. So actually, those are all nodes.
Yeah.
All the subject, the predicate, and the object are all nodes in the graph. Now, the object can be a literal, or it can be another node of one of the other types. So you can actually talk about the predicate. You can talk about the things that link things together. So you can say, Claude Warren is the father of Claude Warren. Okay, because my father had the same name. That's why I'm Junior. So
my father too, by the way.
So there you go. All right. So then we talk about father. You say, well, what does father mean? And you can have a whole structure around if the father can have its own properties. So you can talk about the properties of the things that you're talking about, as well as the things that you're talking about. And so you can do these really interesting traversals. You get this huge graph, and you can do these very interesting traversals and answer lots of questions that you never thought about before. I did a program years ago, a couple years ago now, and the project was to manage extremely large networks. So for telcos, for example, where they have huge networks. And they want to be able to manage the system and understand whether or not the configurations on those network nodes have changed. Mm-hmm. And that's what this application did. But we knew from experience that that's what the customer would come in and say that's what they want to do, and then when they go to execute on that, they want to be able to say, we put this data in, and this is the reason we put this data in. Like, they want to be able to track that. So we wrote a front end where the user could put any data they wanted to. Any property. So if you're talking about name value pairs, right? Any name, any value, right? Put that into the query. And so we put that name value, the name in a namespace for the user, and we would attach it to the object that meant this is the request, and we would pass that through on the graph, and then we would add data to that as it moved through the system. So you'd have this request going through, and you'd get associated with everything that it found in the journey of solving the query. And that would end up in the database. And then they come back later and they say, well, we submitted this test and we know who submitted all of these queries. So show me everything that John submitted. Okay. We never would have thought of that as being a query that you would want to run against the database when we were starting to design it. And so the relational model or the RDF model let us do that.
Is this also, for example, if we deploy applications and redeploy application, and I want to change my database on version 1, and I want to change my database on version 2, I'm running now version 1, then with this graph design of RDF, you don't have the problem that I'm deleting a table in version 1 and version 2 doesn't run other way around. Version 2 deletes table, version 3 doesn't run. There's no backwards compatibility anymore if you delete tables or delete files or delete columns. That's in the RDF model not a problem. Are you deleting things in your database and
RDF,
everything is a first-class system. So
it is also a different concept of the world. It is an open world model whereas our relational models are closed world. So the relational model says, I know everything about the world that I'm modeling. And if it's not in here, then it doesn't exist. Basically, that's the model.
Yeah.
Right? The open world model says, I know about these things, and there are things that I don't know. And if it's not in here, it may exist, or it may not. But I can't answer that. I can't answer that within the model. Right? So you can have graphs that have all of the information from all of the versions, and you can have graphs that have information for one of the versions. And you can query across those graphs. You can join them together, things like that, because they're all talking about the same sort of thing. So you could have a graph that has all of the data for all of the versions forever. Or you can put those all in little bitty graphs and combine them later together. Combine them together later when you need to.
It's an awesome thing for continuous delivery.
Yeah.
Because the biggest problem of continuous delivery is database management.
Okay. I can see that.
Because that if you delete, and in the closed world, if you delete something in your continuous delivery, then you have, at one moment, you've got two versions running at the same time.
Mm-hmm.
But if you do a breaking change in your database, like deleting a table or deleting a column,
right,
the old version is not going to work anymore, and the new version is still working.
Yeah.
But then you have a breaking change, and you're not doing continuous delivery because you have downtime, and you've got problems.
You got problems, yeah.
So if you have a graph system, and everything is a first-class citizen, you're not deleting anything.
You could. You don't have to.
There's always a way.
There's always
But it's
yeah.
it's not giving me breaking changes.
Right. In the graph, it would say, query. You want to query for some column, which is effectively a property now, right? Of an object. So you're querying on that, and if the property doesn't have, if the item doesn't have that property, it just isn't going to show up in your query. It's not going to be there's no response for that, right?
No.
It's basically a null. Anything that doesn't exist is considered like a null.
Still you have to incorporate it then in your programming, but...
Well, no, actually when you run the query, you say, find me all the nodes that have this property. It's not going to, the nodes that don't have the property aren't going to show up.
No, of course not.
Right? Where you say, I want to look at this node and show me this property, and the property will come back and say, well, there's a null value for the property. It's not there. If you actually explicitly ask for the property.
Okay.
So.
Okay.
Yeah.
Complete other question. You said you're a long-time Java programmer.
Yeah.
We have the challenge in Java that you need to manage your memory.
Yeah.
Deep memory. What is the best way to do that? Because in Kubernetes, we always have to set memory limits, and that's the best way to use your program. But how do you manage the heap of your Java application?
Same way you do. You set the limit.
But how do you get
There should be a more efficient way.
There will, if you look inside of Cassandra, they have this problem because they manage, these huge data sets on nodes, right? And they have allocators that allocate, I don't know if they still do now, that may be in the older versions, they have allocators that allocate using like C libraries. So you allocate, you just literally pull it off not managed by Java. So you have to then, deal with that. And then Java now has a new piece that actually sort of manages that sort of interaction.
Magic?
I haven't played with it. I just know that it exists. Says that you can allocate, but talk to external pieces and not worry so much about deallocating the memory, things like that. I'm not sure exactly how it works, to be honest, because I haven't played with it. I've heard that such a thing exists. So,
but there is no good way to find out how much memory my application needs.
No secret sauce.
The secret.
There were pieces introduced in like 9 and 10 that let you ask how big objects are that you weren't able to do before. So I would suspect that you'd be able to ask how much memory is actually consumed by the whole application. But then you're still going to have the issue of, you're going to allocate memory. You can allocate it on the heap or on the stack, and you can allocate it outside of what Java manages. But that's...
Yeah, you mean hidden space and then the other space.
And then all that space that's like mythical space. I would call that mythical space, yeah.
And also you got the other one, the high memory utilization, the big memory you can allocate also.
Yeah.
But yeah, that's for me. It's always a great issue. How much memory does an application need? And it doesn't matter which. If it's a Java application, Java has of course heap, but normal applications also.
As much memory as you want, and you'll just let the operating system swap it out for you.
No, we don't use swap.
See, yeah, we don't use swap either. In Cassandra, it tells you to turn the swap off.
Yeah, we don't use swap.
No.
A swap is...
It's slow.
Yeah, it's stupid.
Well, I don't know about stupid, but all right.
Swap is stupid. You're writing memory to disk.
Yes.
But you want one that have it
At least the disks are getting faster than
but
you
want to have that in memory.
Within the memory.
Why would, if you don't want it in the memory, put it on disk.
If you don't have enough memory, what do you do?
Put more memory in there.
There's a limit.
Yeah, cool.
Yeah, when you reach your limit,
then
if you want more memory, what do you do?
Out of memory. You've got killer.
I don't know. That's not always a viable answer.
And we kill the application.
Yeah. And your patient dies.
Yeah?
Yeah, no, that's not valid.
There's nothing.
That's a valid answer. It's not a good answer in that situation.
No, it's the Kubernetes way, because we think applications are cattle. So we kill the application and start a new one up.
Right, but see, if you're running an application that is running the blood and out the blood oxygen level monitoring
You've got two versions of the application.
I'm a human and sitting in intensive care unit, and you kill the application. That's really not a good.
No, you've got two versions of that application running. You can kill one, and the other one picks it up.
Right.
And then,
yeah, I mean, I suppose you can work it around that way. Yeah. You can argue. I think that there are cases where you can argue that you need more memory than the machine has.
Yeah.
I can think of lots of them in terms of small-scale robotics. I'm building an autonomous chairside table. Okay, so this is my wife has a disability, and if she makes tea in the kitchen and she wants to go sit someplace else and drink her tea, it becomes difficult for her to move it and not spill the tea. Okay. Now we happen to live in an apartment that's all on one floor and it's all hard floors, so it solves many problems. What I'm building is a table that she can then put the tea on and it'll follow her. Alright? Okay. Running that on a Raspberry Pi, there's very limited memory there. So if I'm going to use more memory than the Raspberry Pi has to do things like mapping and things like that, it's going to have to get swapped. And that's a reason it's acceptable to do that.
yeah.
Right? So there are cases where you don't have a lot of memory. Now, absolutely, if you're running...
I think there are edge cases. And
it could be an edge case now, but it may not be an edge case tomorrow. Okay, so I had this discussion with a friend a while back about autonomous cars. Right? Where are we going to go with autonomous cars? And I think that we'll have autonomous cars for a very short period of time. And the reason I think that is I was walking down the road in Galway one day and city center, and there was a truck, and they were unloading this rack of material that was going into a store, into a shop.
Yeah.
And they load that, and they take it in, and they bring the empty rack back out, and they stick it on the truck. And that's how they delivered the goods for the entire market, all the shops along Chop Street. And I thought, if you had an autonomous rack, it could get loaded at the warehouse, and it could drive to the shop, and that would be it.
Yeah.
Right? Okay. And if you put a couple of those together, you could make an autonomous truck, effectively, leave the warehouse, and then the pieces would peel off as they got closer to where they were going, and be at the end of it. All right. So then I started thinking about garbage bins, and how cool would it be if your garbage bin was full, and it would drive itself to the local and dump, and then come back, right?
Yeah.
It's like, that's brilliant.
Maybe put a drone on it and just fly over there. Maybe.
Well, you could fly it, sure. All right. But then It's like, well, all right. Send the kids to school. So what do? You either go out and you send them out and they take the bus, or you get in the car and you drive them, right?
Yeah.
But if they had their own pod, they could get in the pod and they could hook up with the other students that were going to the school and become a school bus and go to the school, right?
Awesome.
And people going to work, same thing. And you would get efficiency.
Image for it.
You get efficiency of aerodynamics by becoming a bigger vehicle and merging together. And so that's why you want to do that, right? Okay. So we're going to have self-driving cars for a period of time because we will have cars. And then we're going to end up with pods, okay, which are really not self-driving cars, and they're much smaller.
Yeah, and they will exchange information and become one great collective.
It can become one great collective, but how much memory are you going to be able to put into a pod and be able to keep it running?
I think Kubernetes is running in those pods.
Yeah, okay.
Because
I don't want my pod to keel over and die because the Kubernetes
what
has
you're
to
running
stop.
then. Okay, this is the greatest thing of Kubernetes and you're running two of those applications simultaneously. So one dies, and you have to program another way. You need to program that your application dies. You're not in. One thing is for sure, we die. So the application, one thing is for sure, the application dies.
Okay.
And so if you can give that application short lifetime and put two together, or three or four, you've got redundancy in more people or more applications. And then if one dies, or one uses too much memory, or one has an application error, or one has something, I don't know, something unforeseen, it dies, you kill it, and starts the boots again. And that concept is vastly differently than I've got one application, it needs to run always, it has to have more memory because my memory is getting full. That's completely a different world in the world that I think your application has. You give it 5 or 10 gigs of memory or MBs, I don't mind, and you still need to size your application, of course. But yeah, it's
So it's possible to have a request for more memory in normal processing than Kubernetes is that anything's going to handle, right? In this case, you're saying it just falls over and the next one picks it up. But if the problem is that in processing the data that is in the environment, you exceed the capability always.
Of course, but I know why you're.
Right.
So if you have it like a data block, you've got memory, it's 1 MBs, and your data block is 2 MBs, and
right.
you want to cramming 2 MBs in 1 MB.
Yeah,
that's not going to work. It's never going to work.
Right.
But you still have to size for that. But if you have your memory is 4 MBs, and you have 2 MB data block, and you're putting 2 of those in, and that's not going to work at the same time, and that application dies, and the other one takes it over.
But then the other one's going to do the same thing.
Now you've got one data block, and you've got more of them. It's
and I think it's only going to work if you have deterministic programming, and I don't know that all solutions have deterministic programming. The table that I'm working on, it's using an RDF graph, and I had to do. I wanted to assign UUIDs to the nodes to be able to talk about some of them, because it's just easier than using anonymous nodes. But it turns out if you do that, then every time you run the program, it'll run slightly differently because the order that it'll look at data will be different.
cool.
So it's not deterministic. So the mapping program, for example, I have this really simple one. I build a room and I put a wall across it with doors on either side. I put the simulated robot on one side and I put the target on the other. And I say, go there. Okay, so it has to find a way. So it finds the wall and it goes, okay, we'll work around the wall, finds the door, gets out. Well, it can run that 5 different times, and it'll have 2 different solutions. It'll find the left door or the right door, right? And the 2 basic solutions. We've got minor variations in there because it's not deterministic. I mean, it's deterministic in that it actually will eventually find the solution.
No, but it's still it's
So now you got 2 Kubernetes running, and they're really running a separate operation, separate backup for the other, they aren't necessarily working on the same solution.
Nope.
So when it fails, the failover is going to be really strange.
No, you have to keep in mind that they have to communicate with each other. So if one fails and the other one is working on the same problem, and he is not there yet, it says they did against the other one. Oh, no, I failed. Oh, I'm going to stop with this. Maybe you've got some overhead but it's more reliable in the end, and it's more work. It's more because you have to think about it. They have to communicate. It's more work. Yeah.
Yeah.
But it's if you're searching for reliability, that's the only thing that's going to work.
Well,
sorry.
Well, it was an intriguing conversation to listen to. But I want to point out something else before we close out this episode, because I see you have a beautiful sticker on your
I have a
shirt.
sticker, yes. The
In the
community over code.
Community over code.
Community over code.
Tell us
Okay.
short what it's about.
All right, the Apache Software Foundation has an annual conference. They have several of them. One in North America, one in Asia, and we haven't had one in the EU or in Europe for a number of years.
Yeah.
And so I am the chair of this year's Community Over Code for the European Union, EU, and we are in Bratislava.
Oh, we'll put that in the show notes so people can. We
We
will put it in the show notes
Okay.
of the podcast.
So the URL is eu.communityovercode, all one word, .org.
Okay.
Cool.
Well, that's easy to remember.
So,
EU.communityovercode.org.
Right.
Okay. Well,
And we look forward to having anybody out there. We've got all kinds of interesting things planned.
okay. Well, we'll make sure the word gets out.
Yeah.
Thank you.
Claude,
Thank you.
thank you very much for taking your time
thank you.
spontaneously joining our podcast.
That was a great conversation.
Because it's
Great fun.
But you can go on for hours. I can imagine.
So we can.
So, thank you, and hope to see you again in the future.
All right.
Yeah,
Thank you.
Like and subscribe.
Like and subscribe, everybody.